Hello friends, this is Jim here with Science Talk, and I thought I would do an update for you on the crazy summer that was in Alaska. Crazy summer of 2019. So I've got information that's the latest, hot off the presses. So let's just get right into it. So we'll start out with the Chukchi Sea, and this had the lowest June to August average for the sea ice in the 41 years that the NSIDC has been collecting data. NSIDC, of course, is National Snow Ice Data Center, part of the University of Colorado in Boulder, Colorado. Beaufort Sea was the fifth lowest. Previous low years were anomalies, but in recent years, a trend is clearly observed. That trend is decreasing sea ice extent. I actually had a little GIF graphic that I wanted to show and share with you. For some reason, I just could not get it to work, could not get it to load, but it's getting pretty low. So this is kind of continuation of some of the graphics I shared with you the first time around when I did a video a couple weeks back on what was happening this summer. So this is the Chukchi and Beaufort Seas combined daily ice extent. Okay, this is for 79 to 2019. The green line is the 2019, that's current. Red line is for 2018. The black line is the 1981 to 2010 median, which means that half of the ice would be extents graphs would be above, and half would be of the ice extent graphs would be below. Think of it as the 50th percentile. Now this is updated through August 24th. So ice north of Alaska continues to melt as of August 24th from National Weather Service Alaska analysis. The closest sea ice to Alaska was about 200 kilometers northeast of Kaktovik. Now Kaktovik is located about here. You see where the R&T of Beaufort is? It's located right there, just off the coast, the north slope coast here. Prudhoe Bay is nearby, and it's a little island. There's actually about 100 people who live there year round. Okay, be that as it may, but they're right there, and you can see how far the ice has receded. Now in the Chukchi Sea over here, there is no ice within 750 kilometers of Alaska. Quite significant. The other thing to note, as I pointed out in the previous video I did on this, look how much sooner the ice starts to disappear. Look how much sooner. It's starting a whole month earlier. That is a very significant part of this. So now, this is through August 31st, and you can see the ice has receded some more. It appears that it's going to start reaching the lowest extent. We'll still have the month of September to go through, so it could even conceivably dip down further. We don't know. We'll collect the data. I'll share it with you, but it's one of the lowest years ever. Sea ice remains far from Alaska waters. Combined Chukchi and Beaufort extents still very slowly falling. The weather pattern this week is likely to support continued decline in extent. So it could even dip down further. That's basically what that is saying. So I'll read this description of the following figure, and this is again from the NSIDC. The Arctic Sea Ice Index, 5-day average sea ice extent for the whole Arctic, as of September 2, is 4.51 million square kilometers and decreasing. This is lower than 2017 or 2018 and would rank as the sixth lowest annual extent since 1979. So here we go. This is the sea ice extent, dated September 2nd. Now I am recording this video on September 5th. So this is pretty much up-to-date information. The white that you see here, that is the sea ice extent. This orange line that you see here, that's the median ice edge from 1981 to 2010, meaning that this is the median. So half the time the ice will be on this side of it, half the times the ice will be on that side of it. Now, obviously it's going to ebb and flow with the seasons. For example, in wintertime, historically, it hasn't been doing that lately, but historically, the ice would, be right up into the Bering Strait, even sometimes out into the Bering Sea. All this Chukchi, Beaufort, just packed in with ice. We're not seeing that anymore. And the next graphic I'm going to show is really a very interesting one. And by the way, here's Novaya Zemlya. Okay, so you got the Barents Sea, you got the Siberian Sea, the Kara, Laptev Seas, all that kind of stuff. This here is Lake Baikal. So this is obviously over Russia, it's China, so on, Kamchatka. But anyway, this is really an interesting graphic. And this is the data is from the Danish government and the courtesy of Kevin Pluk, who posted this. And what this is showing is sea ice thickness as of September 3. So let's look at this here. Let's look at the scale. So you got Greenland, you got Ellesmere Island, the Canadian archipelago, there's Alaska, Bering Strait, Chukchi, Beaufort, Russia, Novaya Zemlya, Scandinavia, etc. The purple is about 0.5 meter to 1 meter thick. The red is 4.5 meters thick. Look at this part right here. Very thin ice, only about 1 meter thick at best. Yeah, you get into here, okay, it's a little thicker, maybe 1.5 meters, maybe up to 2 meters. Get into some greens here, 2.5, 3, maybe 3.5 meters is the thickness that we see here. Like, for example, there. Overall. What this is telling us is that multi-year ice is decreasing. That is what this is telling us. Multi-year ice is ice that survives a summer, summer melting, so that it persists into the winter, and then when the winter freezing takes place, it accrues thickness, and then it survives the next summer, so that you can get ice that's 3, 4, 5, 6 years running, that has survived that long, and it gets pretty thick. That is disappearing. The multi-year sea ice is disappearing. So that's a very telling thing. So when you have the multi-year ice disappearing, you're going to leave more open water. Open water absorbs heat. Multi-year thick ice is very white. That very white surface reflects sunlight energy back into space, albedo. Thinner sea ice can be opaque. So it's not going to necessarily reflect all energy back into space. It will reflect some, but depending on how opaque or how translucent the ice is, some energy will go through and be absorbed by the water. So that's another ramification of having fewer and fewer occurrences of multi-year sea ice. The thinner the ice gets, the increased probability of sunlight energy making it through the ice into the water. Now over here is an Arctic sea ice volume, and if you were to extend this graph on both sides here, it would be sinusoidal, kind of like a sine wave deal, which makes sense. You have the max and mins of the year, ice growing, ice shrinking, etc. So the volume here is in 1,000 cubic kilometers. Okay? And you got 2015, 2016. Well, you got all these different lines here for the different years. The black is for this year, 2019. As you can see, it's current up to about September 3. The gray is the average from 04 to 13 of the sea ice volume. And as you can see, 2019 is on the low end, if not This little green here is 2016 was a pretty low year. You can see that we're having a greatly reduced sea ice uh, volume. So this, as I said, this is a very telling graph, and is indicating the decline of multi-year sea ice, the overall decline of sea ice, period. As I mentioned in my last video, the Chukchi is well on its way to becoming seasonally ice-free. Again, no sea ice greater than 4 meters thick in the Arctic. Now, when you look at this here, why is it thicker here on this side and say over on this side? Keep in mind of the Arctic dipole. Got a high pressure system here, so you got a and then you tend to have low pressure systems here that can concentrate the ice. Remember that during the positive and negative phase, we determine, excuse me, I went through that. Will determine if ice is pushed out of the Fram Strait or contained within the basin. But a lot of it has to do with atmospheric forcing that allows the ice to concentrate. But still, sea ice, multi-year sea ice is disappearing. Sea ice in general is disappearing. And as I mentioned in the video some time ago, the Arctic Ocean could be ice-free in the summertime on a regular basis. And ice-free, to folks who study sea ice, who are oceanographers, basically means 80% of the ice is gone. So you might still see some ice around like 85 degrees on up to 90 degrees. So now let's look at precipitation levels. And by the way, this is data from ACCAP, which is the Alaska Center for Climate Assessment and Policy. That's what the acronym is for. Denali National Park headquarters, with almost a century of climate observations, just finished up the wettest 31 days in that time with a rainfall of nearly 27 centimeters. That's 70% of the annual normal. Same time, the Alaskan BC Visitor Center had 20 and a little over quarter inch of rain. Well, that is a bucket load. And NOAA and TEI and WS, and they collected the data. But look there, here it is, 2019, July 24th, August 23. There it is, that's the most. Now, August is typically the wet month in interior Alaska, but this August has been wet even by August standards. It's just been incredible. Today's the 63rd consecutive day at Utqiagvik, with the low temperatures higher than 36 degrees Fahrenheit or positive 2.2 Celsius. The previous longest such streak was 28 days in 1951, so more than twice as long. For reference, the NCEI 81 to 2010 normal low 10 for August 31st is basically positive 0.6 C. This was sent out on September 1st at 4:37 a.m. So let's take a look at Utqiagvik, which is based near Barrow. Summer June to August average temperature, and this is for 1921 to 2019. So basically quite a long period, almost 100 years. So this line here, grayish, greenish, whatever you want to call it, is the smooth average, okay, of all the data points here. So for example, if you want to know the average June to August summer temperature in 1930, there it is, 40 degrees Fahrenheit. This is the Fahrenheit scale, and you can read it across here as basically 4.5 degrees C. So you have both scales there for cross-referencing. The 10 warmest are in the red dots, the 10 coldest are in the blue dots. Notice that there's no coldest after, looks like about 1976. So all the 10 coldest years were 1976 and earlier. you look at the warmest, okay, yeah, you had one in the mid 20s, and you had one about like 1951 or so. Those are anomaly, but look right here. Yeah, 1, 2, 3. You got 6 of the warmest since that looks like 1998 or so, 99, and you can even throw in a 7 starting in 1989. Yeah, I'll call that 1998. So you have the 7 warmest since 1989. This is amazing. So the average summer temperature was almost 6 degrees C. This is 2.3 degrees C above the 81 to 2010 normal, and second warmest of record. Only 89 was milder, and you can see that dot is a little higher than here. Lack of any cold summers since the early 80s is quite notable. Any cold summers, right? Since the early 80s. That's here. So, things are warming. And of course, the Arctic is warming faster than the other planet, which then has ramifications. As I discussed before, it will affect the jet stream because the gradient for either pressure or temperature is not as great. So any storm systems, like look at Dorian right now, it kind of stalls, right? Any storm systems are going to move slower. So here are the highest temperature for the summer of 2019 recorded around the state. Highest temperatures around Alaska summer 2019, except possibly for the central Aleutians up here. There are almost certain to be highs for the year. Most occurred in late June, early July, except some southern coastal areas. Highest temperatures were in August, like down here, and so on. But look at this here. Okay, there's that 90 degrees in Anchorage. That was a record high. Here's 92 over in Northway. Okay. You know, it's look at all the 90s here. 93, 91, 90, 90, 91, and then high 80s. It was just amazing, absolutely amazing how hot it was. And a part of the reason why it's hot, as I'm going to get to in a bit, is because no sea ice, very little of it, and extremely high sea surface temperatures, making for very warm conditions. Now, in the previous video I showed you what was going on for July. This is for August, and look at the temperature from normal. It's really, it's the southwestern portion of the state and going out the Alaska Peninsula out into the Aleutians, Kodiak Island. Okay, it's just amazingly considerably warmer. Here's your scale. Much warmer, greater than 4 degrees Fahrenheit. That's like 7.6 degrees C. Now, it was a little cooler out here, and the reason it was a little cooler out there, clouds and heavy rain. This is August. So clouds and heavy rain are going to minimize how much solar energy is received. And the reference is Utqiagvik up by Barrow. So August 2019, the temperature departure from normal across Alaska. South central, southwest Alaska had record warm August. The northeast and third was slightly cooler than normal due to clouds and heavy rain. We can say very heavy rain. So there you have it there. And now for the entire summer. Right, this is June, July, August. It is near certainty that Alaska will finish with the second warmest summer on record statewide and the warmest for about half of the state, basically the western half. Incredible. Oh, by the way, these little jagged lines that you see here, that's the road system for Alaska. No roads over here. If you want to get over here, take a plane. So this is the Hall Road, listed as the Dalton Highway. We still call it the Hall Road, that brings supplies up to the oil industrial complex up there. This is the Elliott Highway going out to Manly. This is the Steese going out to Circle. And interesting story about Circle. It was called Circle because folks thought they were on the Arctic Circle. They failed to take into account the curvature of the Earth bending sunlight, so that they were a little south of the Arctic Circle. But anyway, so this here is the Parks Highway to Anchorage. This here is the Richardson that takes you down to Valdez. You got this the Alaska Highway that cuts it through some beautiful scenery there, and you can This is part of the Alcan that takes you out into the Yukon Territory, etc. Up to the Eagle. This is your road system. But don't let it fool you. That's 360 miles. That's over 400 miles. So, but anyway, yeah, and we put our capital where you can't access it by roads. Gotta love that. But you see, it's a very warm summer. Now to the oceans. Oceans around Alaska were hot. Average summer sea surface temperatures were the highest, or second highest, since at least 1900 from the central eastern Bering Sea northward and much to the Gulf of Alaska. This helped contribute to record or near record high air temperatures, and the data is from NOAA's ERSST Volume 5 data, analysis code by climatologist 49. That's Brett Schneider's Twitter handle. He did a lot of the analyses, a lot of the preparation of the graphics I've been sharing with you in these two videos, as did Rick Toman. So again, my thanks to Rick and Brian for providing the graphics that I used. The one that I presented of the sea ice volume, thicker than 4 meters any sea ice, that was courtesy of Kevin Pluk, and the data was via Danish government analyses. So here we go. So this is for the week August 23 to 29, sea surface departure. Now, this is in centigrade or Celsius. See right there? That's about 6 or so. 6, even pushing 7. That's Celsius. Multiply that by 1.8, and you get an idea of how much warmer that is. That'd be about roughly 13, almost 14 degrees Fahrenheit warmer. When you consider water has a higher specific heat capacity, that is a tremendous, incredible amount of energy being absorbed. And that energy is going to transfer into warmer air temperatures. This is the Chukchi. It is really hot. Bering is warm, as is the Gulf of Alaska warm. Now you're going to say, well, what's going on here? Why is it a little cooler there? Well, this is the Yukon Territory, approximately here. You've got the town of Inuvik, right about there or so. That's where the Mackenzie River empties into the Beaufort Sea. Mackenzie River is bringing, meltwater with it. Meltwater, of course, is cold. So you're going to have some mixing of cold water in with the sea. And yes, it's less salty, of course, so it's going to stay stratified at the surface. And we're measuring sea surface temperatures. So that's what this is about. When you look at a lot of the graphs, you see it's a little cooler on the coastal, especially where there is an introduction of riverine water that contains snow melt. So those waters will be cold, and the resulting mixing will keep the temperatures, surface temperatures, cooler. So that's what's going on there. Now for the entire month of August. Pretty much the same thing. Pretty much the same thing. A little warmer here, right? It's still warmer. It's above, 1, maybe 1, 2 degrees C above normal. The Chukchi is the one that really heated up. As I said, this is on its way to becoming seasonally ice-free. So now let's look at some rankings. Here's the so when we look at the rankings of University of Alaska Fairbanks data, so it ranks it from 1, the highest, to 120, the lowest, since 1900. This is for all June to August time frames. So the red is ranked number 1, and when you get way out, here's the blue. I don't have the light blue in here, but it's probably like around 100 or something like that. So ranking number 1 means the warmest. Look at this. There's a lot of number 1 rankings. Right? Then you got number 2s and number 3s and so on. So percentage ranked number 1 is 8.3%. Percent ranked number 120 is 0%. 120 means the coldest. We don't see it. We just don't see it. They didn't put it in the scale here, but if I was to extrapolate, this light blue would probably be somewhere in this vicinity. But look how much, this is all ranked number one, all this bright red here. Very, very warm oceanic temperatures. And a little statistical. Now this is interesting. Months in the last year with sea surface temperatures around Alaska that are A, that's over here, greater than positive 1.5 standard deviations above normal. B, that's this one, less than minus 1.5 standard deviations below normal. In an unchanging world, they should look about the same. And what do we see? All right, based on a total of 12 possible months using the 81 to 2010 climate normal period, same thing here. Okay, so what do we see here? We got this blue. So that's what? That is 6, right? 6 months. But here, there's just so much hotter. So in other words, if this was, remember when I did my intro stat video some time ago, please check it out if you haven't seen it, I talk about the normal distribution. And the normal distribution is symmetrical. So if you go one standard deviation above the mean, it'll look the same as going one standard deviation below the mean, symmetrically wise. That's what this statement's about. In an unchanging world, they should look about the same. These graphs should look the same, but they don't. This is obviously showing a skewing, and a skewing towards more above, standard deviations above the normal. So that's showing. So this is basically a statistical analysis showing that the changes we are observing, the data we are collecting, is significant. Now for the entire planet, okay, not just Gulf of Alaska, Bering, Chukchi, Beaufort Seas, global sea surface temperature. Top 50 warmest months since 1854. So that's quite a few years of data available. Again, this is from Brian Brettschneider, looking at the ERSST source. Global sea surface temperature in August 2019, the warmest on record for this time period. All of the top 50 months have occurred since 2003. And there's August 2019, the warmest global sea surface temperature. August had the warmest global ocean surface temperature on record. All 50 months since 2003. If that is not a trend, I do not know what is a trend then. So when anytime anyone wants to argue with you and say that nothing has happened, it's all made up stuff, you can tell them they're full of it, because they are. So here's the August and summer 2019 Alaska weather and climate highlights, lowlights, maybe if you want to. This is the summer of extremes around Alaska. July was the warmest month of record. The warmest summer in southern mainland Alaska. Severe drought, record rainfall, extensive wildfires, record high, nearly record high sea surface temperature, record low sea ice. So let's just take a look at some of it. Chukchi Sea, the average summer ice extent was the lowest of record, 56% of normal. Okay, we covered that with the graphics I showed you earlier. Nome, an all-time 24-hour rainfall, August 1st to 2nd, 2.5 inches. King Salmon, driest summer, 50% normal. Cold Bay, this is out in the middle of bloody Aleutians, cold, nasty Pacific. Warmest August, 57.4 Fahrenheit. Even Kodiak, warmest August, almost 62 degrees Fahrenheit. Anchorage, the warmest summer, and we had that record high of 90 on July 4th. Okay. McKinley wildfires in August consumed, that's like McKinley State Park, consumed, not to be confused with Denali National Park, but it consumed 50 homes that were destroyed by fire. The wettest August, we touched upon that earlier. Wildfires statewide, almost 2.6 million acres burned, 6th highest past years. Utqiagvik, the wettest summer, almost 5.5 inches. Norway, all-time record high temperature, June 30th, 92 degrees Fahrenheit. I showed you that earlier. Juneau, most days 70 degrees Fahrenheit or higher, 45. Juneau is kind of a cool place. I mean, cool as in temperature-wise. It doesn't really get warm there. Sitka, the driest August. Southern Panhandle, getting down near Ketchikan. Severe drought. Okay, and of course, overall, Alaska, statewide July, the warmest month of record, average 58.1 Fahrenheit. That's from here to there to there to there, all over the place. So there you have it. As with these videos, of course, you can pause it and examine the graphics in more detail at your leisure, if you wish, for your own edification. That's fine. I encourage that. I'm looking for a graphic. I want to do. Here we go. I want to make a comment on this. Okay, if you look at the average for when the sea ice volume is at its greatest, it appears to be in May, and it's at its lowest appears to be in September. Okay, what's going on there? This is the ocean. Sea ice is derived from the oceanic water freezing, but because of the solutes, the salt, and instead you have freezing point depression, so the water actually has to cool to a lower temperature before it starts to freeze. And when it does so, you have brine rejection, so that it's pretty much fresh water that forms the ice. You could melt sea ice and use it. The salt content will be minimal. Well, March is the oceanic winter. Remember, because of the specific heat of water, it takes longer for the water to heat up, takes longer to cool down. There's a lag effect. So there's a lag effect from November, December, January, when solar energy is at its lowest. So there's going to be a lag effect to when the waters will cool down to reflect that low energy input. So, and then shortly after is when the ice will then start freezing. So that's all tied into the specific heat of water. Conversely, in September is the oceanic summer. March is the oceanic winter. September is the oceanic summer because, again, of the lag of absorbing the heat energy, during May, June, July. It takes a while for that energy to be absorbed, the lag effect to heat up the water. So that's why you often hear oceanographers say March is the oceanic winter and September the oceanic summer. So I wanted to mention that. Now, another important ramification of these ice edge is that as the ice is melting, so you have that fresh water that does a little bit of stratification right there at the ice edge. And we actually observe something called ice edge productivity. Ice edge productivity is fueled by this melting water, because then you get a little mini stratification going on there. And so you got the phytoplankton with their nutrients that they get trapped in this little stratified layer, and they start increasing their numbers, undergoing primary productivity, which then drives ecosystem. And it's actually kind of an important ecosystem. So as the sea ice is getting lost, we're going to be losing that little mini ecosystem, and that will have ramifications on all the creatures that depend on food up there. Conversely, I want to get down to this one a little quicker. So when you look at this here, okay, with the warmer waters here, and we have already documented this as oceanographers, diatoms, which are a group of phytoplanktons that prefer cold water, are being replaced by coccolithophorids, which are a group of phytoplanktons that prefer warmer waters. This will have ramifications for zooplankton, and the organisms that feed upon zooplankton, going up to small fish, larger fish, etc. And then, of course, the mammals that feed on the fish. So this is having severe ramifications for the ecosystem. Cod and pollock are going as deep as they can in the water column to find some cold water because the surface water is too warm for them. They are, of course, more of a pelagic or demersal below. Pelagic is open water, demersal is away from the surface, but still, they're seeking further. They're seeking deeper waters, is what I'm trying to say. And the Bering Sea is only about 50 meters deep, so they're kind of being squeezed a bit. But so not only the ramifications for the climate and the weather and the air temperature, all the things I discussed with you, but there's ramifications for the ecosystem, ramifications for the food web and the food chain. So that's other things to keep in mind. So I wanted to mention those a few points there. So anyway, again, my thanks to Rick Tolman and Brian Brettschneider for making available these graphics, all these data so that we can look at this. And I know they're going to keep it coming, so I've already been communicating with them. But there's more to come, and I'll probably just keep doing these updates as the data comes in for what like September shows. It'll be interesting to see what happens with that. So kind of consider this part 2 of the crazy summer of 2019 for Alaska. And I thank you for your time. Hey friends, this is Jim reminding you to subscribe and share my videos. Also, don't forget to click the bell so that you know when I drop a video in. And I'm also asking for you to please support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your continued support.